Hello, everyone. Welcome to today's session. Today, we'll be looking at the second part of Learning Unit 6, which is a chi-squared distribution, where we look at a test of equality of proportions. So, as I had mentioned to you in the first part of this learning unit, the steps are exactly the same for this type of test as it was for your test of independence of association. The only difference is the way in which we write out the null hypothesis. But I've also included here in this example, you'll see that it's a different way that they ask you the question in terms of there's no two-way contingency table, as you will see. So it's just to show you the different possible ways that you can be provided with information for this type of question. And this is, as I said, an instance where you don't have a two-way contingency table. Rather, you have the information provided to you in this paragraph, and you're going to apply it. And again, follow the same steps where you first determine your null and alternate hypotheses. You then determine your region of rejection. You then go on to calculate your test statistic, which we do in the table at the bottom. Same steps as well. You'll see one or two differences here and there, and then we compare our chi-squared statistic that we calculate from here to our region of acceptance and rejection, and we then conclude. So let's look at this question where it says that a study conducted 6 years ago found that 40% of women prefer to shop at Edgar's, 35% prefer Foschini, 15% prefer Truett, and 10% prefer Zara. A recent survey of 500 randomly selected women found that 180 shop at Edgar's, 105 shop at Foschini, 90 shop at Truett, and 125 shop at Zara. Can it be concluded that the current store preferences is the same as that of 6 years ago? Test the hypothesis at the 5% level of significance. So firstly, from the information provided to us, you will see that once again, they have given you the observed frequency because they said to you that from a recent survey, this is what they had found. So the 180 for Foschini, sorry, that was for Edgar's, the 105 for Foschini, the 90 for Truett, and the 125 for Zara are the observed frequencies. And in terms of your expected frequencies, which you will always be required to calculate, they haven't given it to you as actual figures, as you will see here, actual numeric values, but what they have given you are percentages, as you can see, and we're going to apply that percentage to then calculate what the expected frequency actually is, and then apply the normal formula of the observed frequency less the expected squared over the expected and continue from there. So the first step is to write out your null and alternate hypotheses, which, as you know, will be written out in words for this learning unit. Your null hypothesis is always going to say that these two variables, whatever the two variables are, they are the same or they are equal. And your alternate will say that they are different to each other or that they are not equal. So here they wanted to know, can it be concluded that the current store preference is the same as that of 6 years ago? So your null will say that the current store preference is the same as 6 years ago. Current store preference, is the same as 6 years ago. And your alternate will always say that it is different. So you'll say the current store preference is different from that of 6 years ago. Okay, so we know what our null and alternate hypotheses are. Then for our region of rejection, remember it is a one-sided upper tail test always. A chi-squared distribution will always be a one-sided upper tail test. So your diagram looks like this, where anything inclusive of this critical limit or below it is your region of rejection, region of acceptance, sorry, and anything greater than that value is your region of rejection. So here, to determine your critical limit, you're going to go to table 3 of your appendix. You will need two values: the level of significance, which in this case is 5%, written as 0.05, and then also your degree of freedom, which is calculated in this case where you don't have a two-way table, but instead you have information provided to you. You're going to look at how many variables figures that they give to you. So you had figures for Edgar's, Fashini, Truett, and Zara. So that's 1, 2, 3, 4, which makes your degree of freedom 4, and it's calculated as n minus 1, just like we had in learning unit 5. So n minus 1, 4 minus 1, which will give you a degree of freedom of 3. So you're going to take your value of A and your degree of freedom of 3 and go to table 3 of your appendix, which I'm pulling up. So you're looking for an A value of 0.05, a degree of freedom of 3. So 0.05, your A values are found going across the table. And then your degree of freedom is found vertically. So you're looking for 3. And I'd like to zoom that in for you. In line with 3 and 0.05, you have a critical limit of 7.815. So when you draw up that diagram, your critical limit here is 7.815. So let's go back to the question, and you can then continue with that step where again your null said that these two variables are the same, so the current preference is the same. Your alternate will say that the current preference is different to that of 6 years ago. Your diagram now will have your 7.815 as your critical limit. Remember, you will only write out the rejection region. So according to this diagram, you will reject the null hypothesis if the chi-squared statistic is greater than 7.815. So you have step 2. Step 3 is then to calculate your test statistic. As I said to you, the observed frequencies were provided to you here, where they said 180 preferred Edgar's, 105 preferred Fashini, 90 preferred Truett, and 125 preferred Zara. So then you're going to look at what percentage they gave you for each respective different type of shop. So they said to you that the study found that 40% of women preferred to shop at Edgar's, 35% preferred to shop at Fashini. So remember, this is Edgar's, Fashini, Truett, and Zara. And as you can see, they've included a column here which is to note down your percentage. So I'm going to write down that respective percentage. 40% was Edgar's, 35% was Fashini, 15% was Truett, and 10% was Zara. Now, you want to know, what do we multiply these percentages by in order to give us our expected frequency? What we multiply it by is the sum of your observed frequencies. So you're going to add up the 180, the 105, the 90, and the 125. That gives us a total of 500. And then you're going to say that 500 multiplied by the 40% would give you the respective expected frequency, which is 200. Then 500 times 35% would give you the 175. Then 500 times 15% would give you 75. And 500 times 10% would give you 50. So now you have the observed frequency and the expected frequency that goes into this calculation. So You can then say for the first one, remember it's observed minus the expected. So 180 minus 200. You'll square that and it's over the expected frequency of 200. So that would give a figure of exactly 2. Then the next one would be 105 minus 175. And then you'll square that and it's over 175, the expected frequency. That's 28. Please don't be alarmed if the figures are large. It's perfectly normal as long as you're following the form. Then you have 90 minus 75 squared and then over 75. So that's 3. And then 125 minus 50 squared over 50. So that would be 112.5. Then you're just going to sum those up. It would give you your chi-squared statistic, which is 145.5. All you'll do now is compare this test statistic to your region of acceptance and rejection. This would naturally fall onto the right-hand side somewhere. It's quite a large number, which is then your rejection region. And so for step 5, you will say that you reject your null hypothesis, which indicates to us, or which means, and to help you to understand what you mean when you say that you reject the null hypothesis, look at what the null said. And if you're saying that you reject this, this means that the alternate is true, which means that this indicates the current store preferences are different. So store preferences are different to that of 6 years ago. So this is what you mean when you say that you are rejecting the null hypothesis. You're saying then essentially that the null was not true. The preferences are not the same that of 6 years ago, which indicates that the store preferences are then different to that of 6 years ago. Okay, so that's it for the equality of proportions test. As you can see, exact same steps followed. It's just that I like the idea of showing you a different example where you don't have a two-way contingency table. It helps to prepare you for the different types of questions that you'll come across. And it also looks at the different ways that they can test you on your chi-square distribution. That's it for today. I will chat to you again soon where we will be looking at the Learning Unit 7 sections, which are the moving averages methods and the linear regression analysis. Thank you, guys.